Okay guys, here is our first example. Question says evaluate the slope. The following functions y equals 2x plus 1, y equals x squared, and this at the point x equals minus 1. So evaluating the slope simply means you should differentiate if you need to prove that in the previous explanation. So this means you should differentiate. So we know that the slope by first principle of differentiation is actually dy dx, and that is f prime of x, same notation, and that is the limit of f of x plus delta x minus f of x divided by delta x as delta x tends to 0. Okay, so by definition we have this. So our f of x here is the y. That's only we can place y can take the place of f of x. It takes time. So y is a dependent variable which depends on x. So our f of x is actually 2x plus 1. Our f of x plus delta x is actually going to be, so anyway I see x in this function, I place x plus delta x, so that's going to be 2, which is now x plus delta x plus 1. So plugging these two guys into this formula, we're going to have that f prime of x is actually the limit of 2 open bracket x plus delta x plus 1 minus 2x plus 1 divided by delta x as delta x tends to 0. Okay, so we're almost done. If we open this bracket up, we're going to have the limit of 2x plus 2 delta x plus 1 minus 2x minus 1 divided by delta x as delta x tends to 0. So this guy goes off, this guy is not. So I'm going to have the limit of 2 delta x divided by delta x as delta x tends to 0. So actually be the limit of 2 as delta x tends to 0. So this delta x cancel out, that's how we do it. And the limit of a constant from the law of limits, it is that constant. So the limit of 2 is 2. So this is the slope of this function. And we are supposed to evaluate this slope at this point. But because this point, this value doesn't have an x, there's no x there, so there's no point evaluating at that point. So the slope is constant. This result means that the slope is constant, and it's just like what I told you earlier, that for the straight line the slope is always constant. Actually, this is a linear function. The function here is a linear function. So if you plot this graph, you're going to get a straight line. And I told you that if you obtain 2 points on the straight line and find the slope, you always get the same results. It is a constant. So you don't need to evaluate it at -1 again because it doesn't depend on x. And if there's an x here, then the slope varies. I hope that is taken. Okay, let's evaluate question 2. So this is a quadratic function. For the quadratic function, the slope is equal to you see that one. So let's say this, we are going to have that the slope. We already know by definition, so I'm not going to be writing the formula again. I assume you know that already, and that's going to be the limits of that's supposed to be f of x plus delta x. So add delta x to this as x plus delta x, because the function is squared minus the original function as x squared divided by delta x as delta x tends to 0. So we are going to have that this will now be the limit of x squared plus 2x delta x plus delta x all squared minus x squared divided delta x as delta x tends to 0. And we are going to have this to be this guy cancels out. So we're going to have the limits of 2x delta x plus delta x all squared divided by delta x as delta x tends to 0. So this absolute value there simply means that it can be negative or positive. It can be negative. The square of a negative number will get positive. Likewise, square of a positive number will get positive. So what does it mean? So this is going to be 1 delta x equals 1 delta x equals 1 delta x. So I'm going to have a limit of 2x plus delta x. The absolute value disappears as delta x tends to 0. So now, in this case, we're having delta x. So we're supposed to evaluate this at put delta x to be 0. So that's going to be 2x plus 0. That will be 2x. So you can see the slope depends on x. It is not constant. Because it depends on x, it is not constant. And that is why I told you that anytime we have a curve, the slope along that curve is different. So you evaluate the slope at each point. So let's just evaluate the slope at this point x equals minus 1. So therefore, the slope at x equals minus 1 will now be, we used to use the symbol, say divide the x at minus 1, and then it's at x equals minus 1. So it's going to be 2 to the bracket of minus 1 minus x at minus 1, and that is actually minus 2. If you're evaluating it at another point, maybe let's say 0, the slope will be 0. If you're evaluating it at maybe 3, that will be 6, and so on and so forth. And that is why the slope is not constant. Okay, for the third question, so evaluate the slope. This is just f. So to find the slope, that is the differentiation. F prime of x is going to be the limit of f of x plus delta x. And the f of x plus delta x is simply just increase this by delta x. That's 1 over x plus delta x minus 1 over x. This is f of x plus delta x divided by delta x as the delta x times 0. So this is by definition, nothing else. So we find the LCM of this, and this is going to be the limit of x plus delta x, and this will be x minus, this is going to be x plus delta x, everything here divided by as delta x tends to 0. Okay, so if we open this up, this comment, these guys can drop. So we are going to have the limit of x minus delta x divided by x plus delta x as delta x tends to 0, and this guy cancels out with the limit of minus delta x divided by x plus delta x as delta x tends to 0. So this delta x and this delta x, and that will be limit of minus 1 divided by x, and of x plus delta x as delta x tends to 0. So if we replace this delta x with 0, so we need to have minus 1 divided by x plus 0, and it should be minus 1 over x squared. This is also not a constant. It changes with the respective values of x. So let us evaluate the slope at that point. That is f prime of x at x equals minus 1. I'm going to add it to be minus 1 divided by minus 1 squared. That's minus 1 divided by 1, which is minus 1. Okay guys, so this is all on the first principle of differentiation. This method is just a way of avoiding the other methods of differentiation by making use of limits. So all we did in this is just to evaluate the limits of this function with this first principle formula I gave you earlier. Okay, so thanks for watching, and don't forget to subscribe and like this video, and I'd like to hear your comments on this. Thank you.